Okay, so and the last one today in this section, in this track, will be Mr. Tran from the Ho Chi Minh University of Technology in Vietnam, of course. And his topic is comparative tensile behavior and failure mechanism of laser powder fusion, titanium, lattice gyroid versus Schwarz-D. So, the stage is yours, and you can start when you are ready. And please, 10 minutes and 5 minutes.
Okay, so I am Tuan-Duc, and I'm from Ho Chi Minh City University of Technology. And on behalf of my co-authors from VSB Technical University of Australia, today I'm giving a presentation on tensile behavior of LPBF, titanium 64 TPMF lattices, gyroid versus Schwarz-D. And this is the list of abbreviations and nomenclature that we used in this presentation, as well as the following part, as in our manuscript. Okay, and earlier, Mr. Shiri and other professors has presented about LPBF thoroughly and carefully, so I won't describe this process again. And on the picture on the right, you can see some samples that were printed or fabricated using this method. In terms of research background, firstly, AN or additive manufacture enables the fabrication of high geometry complexity components. Titanium 64 is light and has high strain to weight ratio. And finally, lattice structures allow savings on weight and materials. As shown in the figure, you can see this is the solid component with 100% solid and maximum weight. And after the second step and the first step is reduced, and this is optimized in terms of weight and materials. And the research gap, tensile behavior of lattice structures, is less studied than compressive behavior. The potential for further reduction of relative density in existing designs. And lastly, the influence of LPBF effects on TPMF tensile failure mechanism remains unclear. So that leads to the objectives. First, we want to reduce the relative density on the 3D designs. Then we evaluate the fabrication quality of different lattice structures. So we want to see if it can be printed. And then we investigate tensile behavior of the printable lattices. And finally, we compare the failure mechanisms and conduct microscopic observation to explain why was it. So the method overview consists of 4 mainstays. First, design. We use the anti-artified 2025.1 for designing because it offers us with a number of lattice designs. And then we use the Tran Future 1000 machines for the printing step. And in tensile test, in step 3, we use the testometric M550 CT. And finally, in the fourth step, microscopy, we use the Kenyon's optical microscope. And these are the lattice designs that we compare in this research. On the left is gyroid with the relative density of 19.9% and Schwarz-D on the right with the relative density of 19.6%. Okay, so why are gyroid and Schwarz-D? Because when we reduce or we limit the relative density below 20%, these lattices are the ones that were printable, which means it didn't fail after the printing step. And also, the same relative density ensures the same base for any comparisons in the future. And to set up an experiment, as I said, we use the machines through print and testometric, and here are the printing parameters as well as the tensile test setting data. And this is the diagram that shows the tensile specimen with lattice in cross section, and all the numbers are shown in millimeters. And this is the lattice region, and those are solid. A little bit about the related equation. The following equation is used to calculate the stress in lattice as A effective equal rho star times A nominal. Okay, and this is the most important part we want to investigate. Is first tensile test results of gyroid samples. As you can see, this is the last row show the average and the standard deviations of gyroid samples. We have 5 samples totally. And next is the results of the Schwarz-D samples. And when we compare side by side, we can see that gyroid perform much better in all aspects, including yield strength, ultimate tensile strength, strain at failure, and Young's modulus, especially for strain at failure. And this is the standard deviation comparison between two lattices. When it comes to the stress-strain behavior, this is the diagram of 5 stress-strain curves of the 5 gyroid samples. And here is the curves, of the Schwarz-D. And again, when we compare them side by side, we can see quite differences. First of all, is the lines. I would say is longer in strain and higher in stress. And the most noticeable thing is that the line after failure. When we take a look at the lines in gyroid, you can see a stair-like line. And over there, in Schwarz-D lines, it seems like a linear line after failure. So why is it? It can be explained using the microscopy pictures. On the upper rows, we have 3 pictures showing the gyroid, and the 3 below, you can see the Schwarz-D. First of all, the breaking point occur in terms of gyroid, it occurs inside the lattice region. But in Schwarz-D, it breaks right at the joining surface between the solid and the lattice region. So, in gyroid, I can say, looking at the pictures, we conclude that it has good bonding as the powder was melted properly and the joints was formed nicely. And in terms of Schwarz-D, the powder was loosely melted and holes with the diameters of up to 100 micrometers can be seen throughout the surface. So, as we can see, despite only 0.3 difference in relative density, significant porosity was observed in the Schwarz-D. So, the key discussion is that gyroid features a smooth geometry, so it has better stress distribution, and Schwarz-D has sharp transitions, so it has defects and has weak interfaces. In conclusion, should the gyroid structure is stronger and more ductile, the 2 lattices exhibit different failure mechanisms, and finally, geometry strongly influences mechanical performance. And in the future, it can be improved using scanning electron microscopy or microcity or FEA simulation to develop our work. So that is for my presentation. Thank you for your attention.
Thank you. So, any questions for audience? No. I also don't have a question.
Yes.
There is a question. Please.
see the slide, you take straight texture of the spiderman. No. Spiderman of
The specimen.
spiderman.
This one.
Right? Yeah. The spiderman is follow EFTM.
Yes, it is
EA. EA.
yes, it does follow the ASTM standard. And actually, this one was used already by one of my co-authors.
Mm-hmm. I ask you a question. The area.
The lattice
Area change from large to small. Such that you take area.
Okay.
Area change from large to small.
You want to know if there was any difference in the gap, like it can be.
If you Spiderman record, the Spiderman record, you calculated the matlock of tensor strength.
Sorry, but I couldn't. Yeah.
You calculated the matlock of tensor strength of Spiderman.
Maybe you can invent them.
Two parameters different.
Parameters?
Lump of the joint, lump of the specimen, different tensor strength specimen.
Anh có thể nói tiếng Việt hoặc là đấy.
Khác nha, tức là cái mẫu thử này là ok, anh làm theo cái tiêu chuẩn đúng không, ATN T8 đúng không, nhưng mà cái giao diện của nó, cái tiết diện á, cái diện tích á, nó sẽ thay đổi đúng không. Anh kéo khi mà nó đứt thì ban đầu nó sẽ lớn đúng không, khi mà nó gần đứt rồi nó sẽ nhỏ dần đúng không. Như vậy thì mình tính ra là tính lực kéo hay là tính ứng suất khác nhau, hai thông số đó khác nhau hoàn toàn.
Không, đây nó tính bằng ứng suất engineering.
Đúng rồi, tính ứng suất thì ra ứng suất mà ra MA mà
Không phải là cái
nhưng mà ra ứng suất là khó lắm, tại
không
vì
phải nó không ra cái true set, nó ra cái engineering, sau đấy mình quy đổi sang cái true set.
Đúng rồi, tức là quy đổi là mình tính kích thước chuẩn đúng không, mình quy đổi nhưng mà cái thông số đó nó sẽ thay đổi. Ví dụ khi anh ra kết quả là cái đồ thị anh ra nó sẽ thay đổi chứ nó không theo một cái đường, đúng không, anh hiểu không? Cho nên ví dụ như mình ra cái số 60 MPa cạnh 50 MPa thì lúc đấy là nó đứt ra rồi, nhưng mà lúc đấy thì nó tương ứng với diện tích, đâu phải là diện tích mình quy đổi. Lúc đấy cái diện tích nó nhỏ xíu rồi sao đó, chứ là nó khó đấy, nó khó là chỉ cái thông số đấy. Thông số đấy thì nên theo mình là để lực kéo chứ đừng để ứng suất, nên để là lực kéo đừng để ứng suất.
He means the parameters will be
Tất
the
nhiên
force
mình tính
load,
được, nhưng mà nó sẽ khó.
the max force load, not in the strength. You mean the F max. Maximum of load, yeah. Instead of strength, maybe it's.
Yeah, so he suggests us to in our result we should use the maximum load force instead of
maximum load force.
because the lattice structure is
Thay đổi.
unpredicted. I would say it can change during the test. So it's better to include in load force instead of stress. Okay, so yeah, that's a good suggestion, and our team might investigate further on that aspect. Thank you, sir. And Jerry?
Okay, yeah, thank you for the question. It was a good point. I just want to say that because I was creating this, so maybe we can lattice because you know when you predict something solid and then you come to the small lattice structure, it can be changed into parameters because I don't know why there is some porosity in the Schwarz heat. It should be not be so much porosity. I think maybe there was some failure with the machine or something like that because we had some trouble with this machine after that. So maybe we can repeat it and try it again in the future. Okay. Yeah. Okay. So yeah, thank you very much. I will give you the certificate. One more question. Okay.
Another question for you. I don't know what you fabrication this specimen with the powder TI.
Yeah, titanium 64. Yeah.
What machine or method you can produce
Oh yes, you mean we use this Tuan-Duc 1000 for fabricating.
In đây
Can
ạ.
you show me?
Nó in.
We have the name here. Yeah. As I said, we use Tuan-Duc 1000 for printing, and this is the machine for tensile test. This is the microscope.
Chỉ nói cái in thôi.
Yeah. So this is the machine we use for printing.
Nhưng mà thầy hỏi là làm sao để in được ra cái hình đấy.
Cái phương pháp đấy là phải mẫu
Yeah, I skipped that earlier because Jerry had already talked about that.
Đây.
We use this one, the LPPF process. So basically, we have like this is the titanium 64 powder, and we have like a blend to spread the powder, and a laser beam is directed by a moving mirror, and it's melt the powder to form the objects or the components, and it does like layer by layer until it finished.
I know, but I did not see the two specimen in your.
Thầy bảo là cái hình đấy sao nó không giống cái hình ông
There's
kia.
missing of the specimen before testing. So
I think it's very difficult to produce this specimen in the fun.
you want to know if it's difficult?
Yeah. How you measure the dimension?
Accuracy of dimension of the specimen.
The dimension, like the diameters of the specimen? Yeah, as I said, I use the standard of STM28, so
Ý thầy làm sao để kiểm tra kích thước ấy, kiểm tra kích thước mẫu ấy.
Or like after printing? After printing? Yeah, okay, so an author in our team did it, and he ensured that the printed specimen was precise in terms of diameters.
Ok, để anh nói với thầy cho.
I think your idea is very
difficult.
Romantic. So, thank you for
your questions.
Cái mẫu này nó sẽ đầu tiên nó dùng két này, két nó vẽ cái mẫu này ra, sau đấy nó sẽ slide sang STL, cái file này là chuyên để cho in 3D. Xong rồi cái file này, dùng cái file này để in thì nó sẽ in từng lớp một. Ví dụ nhá, cái hình của anh là thế này đúng không? Thế này đúng không? Thì đầu tiên là nó chỉ in cái này thôi, xong tiếp tục lên đây là nó lại in lên lớp tiếp theo, nên nó in từng lớp một. Mà cái này đều là một, in xong nó lại gạt, xong nó in.
Tức là nó sẽ không có kích thước, nó sẽ gạt qua để đảm bảo kích thước.
Guys, if we can discuss it on Galataner because
Okay.
this topic is really interesting for you, and I'd be glad also to speak with you. But right now we need to continue and finish.
Okay,
So.
thank you.
Okay, so this is the end of this section. I'm not sure when. Okay, so in 20 minutes there will be some closing ceremony. I think it will be in the main room where we'll be starting. And after that, of course, you all are welcome for the gala dinner. And also, if you have here the poster and you want to take it, you can take it with you. It's because it's the gift from us if you have the poster, but most of you have the presentation, so you don't have the poster. So once more, thank you to everybody. Thank you to also guys. Thank you. Thank you.
Thank you.
And also thank you, my co-chairman, and see you at the gala dinner.
Thằng em sinh viên báo cáo bị các thầy quay kinh quá. Rồi chúc mừng.
Chúc mừng bạn.
Dạ, em cảm ơn thầy.
Không, cái này thực ra rất là hay, nhưng mà nó lại phải có cái nghi thức hầu hơn.
Dạ.
Vâng. Lần đầu báo cáo bị các thầy quay kinh quá.
Bạn là tiến sĩ đâu?
Không, nó sinh viên nhưng mà nó có mấy tháng mới xét. Xét là